respect for somebody who lives in a Wild West town of Phoenix. This is a.
I am, and I'm actually here,
yeah.
So that's nice.
This track is entitled "Dude, Where's My Horse?" It's.
I appreciate that. Yeah, we keep the horses out back.
I had a great time in Phoenix. I love.
Thank you.
I love the city.
Appreciate that.
Love the state of Arizona. Wonderful place. Let me shut that off. I'm sorry. Hey, the last episode. I've really enjoyed doing this series all the way through, and I think now we kind of get to the kind of the culmination of things when we can really start to dig in and look at debugging. I don't think this is an easy thing to do with microservices in the modern world.
No, I mean, when you take your monolith and you split it up into a bunch of different things, and, you used to be able to just say, I know where the issue is. It's right. It's the monolith right here. It's either that or the database. But now you split it up into a bunch of different things. It could be a murder mystery, like to try to figure that out.
I think that's a lovely way to put it. You got Poirot and Miss Marple kind of wandering around, trying to work out who hit the API with the pipe in the
study.
Yes.
Right.
So what?
Yeah. So this is a continuation of the series that we've been doing for the last 2 months now. I think we've been pretty good about doing it every week. And this is all based on the content that we put together for KubeCon North America 2019. And it's focused on developers and how developers start going down this path of microservices and cloud native architectures.
Yeah.
And what are some of the tools and infrastructure that can help. And so we've been looking at this through the lens of Service Mesh, specifically Consul Service Mesh, and some of the tools around it to help with tracing and Canary automation. And now we'll be talking today about debugging. So yeah, I'm pretty excited about this.
I dig. Oh, we got a special guest. 1 second. Just for Betty. She'll be here in a second. But yeah, I think this is a really, really complicated thing for many people to kind of figure out on their own. But actually, I think when you dig into it, it really isn't that complicated. It's just kind of like finding all of those various different component pieces and being able to kind of stick them all together. The reason I'm kind of looking around is because my dog's troubling me here. I promised Betty that Pan Bear would make an appearance, and you did it, Pan Bear. Are you going to teach us some debugging on microservices? She says I will teach you how to debug some lovely snacks later on if you're interested. Seem to have lost your audio there, Christian.
Oh, you did.
There we
Sorry
go.
about that.
You're all good.
What was the dog's name? Panda Bear?
Pan Bear. So it's
Pan.
Yeah, it's Farsi for cotton ball.
Oh, okay. All right. Very good. Well, thanks for stopping by, Pan Bear.
She says you're welcome, and if you're interested in learning a thing about DevOps or anything like that, to drop by anytime. She knows a lot.
Very good. Actually, I'll be in London in about a week and a half, so we'll talk DevOps.
Awesome. Let's get
cool. So yeah, let's take a look at where we ended last episode, which was exploring Canary deployments and giving developers the tools to release code into production in a more controlled and a way to lower the risk of making these changes so that we don't impact everyone when we make these changes.
Yeah. Yeah, but we didn't actually discuss, well, how do you find out where the problem is? Well, obviously the tracing tells you, but it doesn't give you the precise location.
Right. So let's pick it up from there. And let's come back to, you should be able to see my screen where we have our Visual Studio running in the web browser, I might add, which is pretty handy, especially when you're building a workshop and you want to make this accessible to people. But so what we have on the bottom here in our terminal is, so we'll call our service. And so just to recall, the services kind of look like this. We have a web service. Actually, let's just come over here. Yeah, pod. We have a web service right here that is calling various collaborator services. And in a second, we'll take a look at what that chain looks like. But at the end, we're calling a payment service, which has two deployments. So we have the payment. Let me clean some of this noise up. We have the original blue deployment, and we have a newer green deployment, which is where we ended up with at the end of our last session, where we would show Canary automation and control over being able to route to the various new, the old payment service and then the new payment service. So now when we call into our microservices, excuse me, we're going to be calling in through the API gateway that we have here. We're using Gloo to manage ingress into our service mesh and into our collection of services. But so when we make the call here, you'll notice a couple things. One, it hangs a little bit, all right? Okay, and then we're able to see this chain of calls.
Yeah.
So web goes to API v1, which then calls into one of the payment services. We saw that it hung right there, and in fact, it proactively timed out.
Yeah.
Which is good.
But
then if we call it sometimes, well, this one will also look like it will hang. But if we call it sometimes, then it should return a little faster, and with 200s, right? So we get, excuse me, we get a load balancing effect because we're using the Canary automation to split it. That's where we left it 50-50 in the last episode. And we get this kind of behavior.
Yeah, and that 50-50 split it's based over a period of time. So you're not going to get an exact kind of 2-for-1, but it will, over say 100 requests, we should have pretty much 50-50. That's generally the way things work out. And this is happening at layer 7.
Exactly. So this is happening at the request level, at the protocol level, and we're routing per request. We're not load balancing new connections coming in, right? It's per request. We're using Envoy under it, right? So Gloo uses Envoy under the covers. Consul Service Mesh uses Envoy under the covers. Envoy has kind of become this application networking framework, and that kind of shows up in these types of tools, and it's awesome. So.
And I'm guessing because everything is protocol aware, you can probably configure something in Gloo that again understands that we've received a 500 and probably issue an automated retries.
Exactly. Yep. We can program retries, circuit breaking, all of the things that you can see in Envoy. And actually, if you look at, I think it was episode 2 of this series, where we looked at the difference between an API gateway and a service mesh. Right? So there's overlap, obviously, in the technology that it uses, in some of its capabilities. But if you go back to that episode, we sort of iron out the why is an API gateway different than a service mesh.
And we'll stick the link for that up there for folks to go back and review, because I thought that was really interesting. Personally.
Yeah, that was a great episode. So we see here, we're load balancing between these various backend services. We're hitting some errors on some. We looked in, I believe, the 3rd episode at instrumenting our code with distributed tracing. Right? So we showed Jaeger and how we can track the call stack, if you will, through the various microservices. If we click on Find Traces down here, we can see the last few calls that we made, some of the ones that succeeded, We can see web called API called payment, but then we can also see the ones that didn't complete so successfully, right? Now, we know we deployed the green version of our service as we made some changes and we made a deployment there, and we're using the Canary automation to control who actually sees these changes. But what we can do when we find situations like this is actually debug into the services.
Yeah.
Now, what we're going to take a look at is.
Oh, sorry, Christian, dude. Can you just zoom up just a touch there for some folks at home?
Here in the browser.
Yeah, maybe just both your yeah, that looks perfect.
That looks better.
Yeah, that's probably better.
Okay.
It's hard to say. I've got such a huge screen. Bad.
And I've actually shrunk the resolution on my main screen here, so I was hoping that it would look a little bit bigger there. But okay, yeah, I've improved that the text size a little bit more. Hopefully that works.
That looks cool.
But what we want to do here is in our new service, in our payments green service, we want to be able to debug into. So here's the code. We can see we've made some changes to it, accommodating what we did in the previous session. We switched out the HTTP client and added some imports and so on. But what we would like to do is be able to debug. Now, what we're going to use a tool here called Squash. Squash. Now, this is an open source project from Solo that allows you to debug into your set of microservices running on Kubernetes, regardless of what programming language they're written in. So right now, we'll show you how to do the debugging, but we'll do it. The code for this is written in Golang, but we support, if you click on debuggers over here, we support various languages, programming languages. So the similar effect can be had with however you deploy your applications and write them.
So
what we're going to do, yes, go ahead.
You support monolithic dinosaur languages like Java?
We do, because people use it. I mean, that's still out there. And so, whether it's the new fancy ones or the old dinosaur ones, your microservice environment is probably going to be heterogeneous, and yeah, we support that.
I may not have much facial hair, but I'm all about the hipster line.
Absolutely, Haskell. Right, so let's open up the VS Code plugins, and we start typing Squash. So this will give us an interface to select the services that we want to debug. And in this case, it's running in the default namespace. If we type payment, we can refine our search down. We're gonna debug into the green service. That's our new service that we deployed. And if we look inside the pod, we see we have the Consul Service Mesh sidecar running, as well as a little helper sidecar running with the actual service here.
So just for the folks who from home who are watching here, this I absolutely love, because all of that information around what the pod is, the container in the pod, the Squash debugger is actually just making that. I just click.
Yep.
That's a really, really lovely developer experience. Real sort of props to the team who developed that.
Thank you. Yep. I'll relay that back. And so we have this IDE plugin inside of VS Code here. You can do all this from the command line as well. You can do remote port forwarding, so you can hook up a different IDE that doesn't have a plugin natively. But in VS Code here, we can see we have the plugin helps streamline setting this stuff up. Now, if I click on payment, now we can check the debugger that we would like to use. And we'll use Delve this is a Golang process. And we give this a second. Now, behind the scenes, what it's doing is it's spinning up a pod that then will discover where the process is and attach the debugger. So the debugger is running in this pod. It's running in a headless mode in this case, and is connecting back to the IDE. This message. So you can see here now we're in debug mode. And if we click, let's say, right here, where we create a request, we can see we set a breakpoint. And then now, if I curl the service again, we see we are hanging. We should, oh no, that one didn't hang. Okay, it was just a little bit slow. Oh, did it?
Yeah, we got a breakpoint there. That's
we
did
awesome. We did hit a breakpoint. Here, let's let it continue. You know what I've noticed also is that since this is running on, actually, is this one running? No, I don't know. Let's try that again.
It's probably
that one worked. That one worked. Come on, load balancer. That one didn't work. It slowed down, and we can see that it indeed did hit, and then ended up the timeout kicked in, but we're still inside the service here. And now we're running in Kubernetes, running at one of our microservices. We've connected our IDE to it, and now we can do step-by-step debugging using the tooling here in VS Code. Now, if we try step over this, we can see, oh, that one completed fast. Let's try.
Oh, so this is because the upstream service is dropping the connection when it times out. But
let's try that again. We should end up seeing, or you know what? Maybe the source code's not lining up.
No, I think it's the upstream service is dropping the connection, and then it's kind of all just hanging up. But this is pretty impressive. Like so let's talk about this source code lining up thing. So, I mean, that's a thing. I don't think that's a real problem, because if you kind of take an approach of versioning code and tagging code, but you do have to have that. You do have to the code that you're running in your browser that you've got there has to be the same code that's deployed into the pod.
Exactly.
It's been baked into whatever container, or if it's a compiled application like Golang, it's been compiled, and that's the app there. The two have to be aligned in order for this step debugging process to work correctly.
That's correct. Yep. All right, let's see if we can. There we go. And we step over. That one seems to be going just fine. Yeah. So I mean, it is possible that this isn't lining up specifically, but
it's the timeouts, I think.
Or it's a live demo, and that's what's screwing me up here.
Always the live demo.
But nevertheless, the workflow is through the here. I click stop again, and I'll show it one more time. Through the IDE, where our application, our service is running in. So through the combination of distributed tracing and log, kind of troubleshooting, it can kind of help narrow it down, but that can't get you inside your code.
Yeah.
And Squash will greatly simplify the ability to get into your service and connect up to it and debug it. So we come back here.
I mean, I was unduly kind of sarcastic about sort of Java earlier on, but I'll be honest with you. Anybody who's programmed Go, if you've ever debugged a service, you know that your most commonly used approach for debugging is format.println, and that ain't pretty.
Yeah.
But this is, in my humble opinion, a huge advancement in technology.
Yeah. Now, the other interesting thing that I want to show you in terms of debugging here is that here. Let's hit stop. Is that when we're debugging here, we're connecting up to the actual workload running inside of Kubernetes.
Yeah.
Now, if you're in a production environment, that might not be feasible. Mm-hmm. Not very many of our enterprise customers have direct access to connect their IDEs into production. But what we can do in that case is through Envoy, through Gloo, through the service mesh, the requests are traveling through the Envoy proxies, right? So what we can do is record the requests as they're happening, and for errors, we can save the requests, put them off into a file system or a database somewhere, and then be able to pull them back in a different environment, same environment or different environment, and recreate the call chain that happened against services that you might then have the ability to go debug into.
That's not true. That is not possible, right? Seriously?
Well, until Service Mesh and Envoy came along, you would have to kind of hand code that and build that in, and it became pretty messy. But
I've done my fair share of trying to grep log files to do replay, and it ain't pretty. This I'm looking forward to.
So let's take a look at what we have. So we have what we've done at Solo. So what we're doing at Solo really is, how do we lay the foundation of this network abstraction? So we have from the edge into the cluster, your gateways, your service mesh, all this stuff provides a nice API on top of what's happening in your network and the ability to control it, right? And so what we feel is that let's help people be successful with Service Mesh and adopting this Envoy-based technology, so that we can build the stuff on top of it that really matters, like Canary automation, right? So instead of going there and hand typing, all right, let's change the traffic from 50% to 10% and so forth. Let's build a control loop to automate the operator to actually do that. And let's build tools to be able to debug microservices when when things go wrong. So Loop is another example of building on top of this abstraction.
Yeah.
If we come in here and we take a look at what's deployed, we see we have the loop, no pun intended, the control loop. That loop is running to be able to see what's happening in the system.
Yeah.
To get access to it, let's port forward things correctly. All right. So now if we do loop control list and cross fingers, okay, we see that we do actually have some. This was a bit unexpected. I think I didn't clean up after the previous run to make sure that everything was working. But you can see for any of those 500s, it looks like we have some calls coming in that maybe Gloo does some automatic discovery of services, so we can see that some of these calls are coming in and they fail. But Loop has been collecting the failed calls, and the way we configured that is, if we come in here and look at our tap resource, we see we can specify the predicate, how we want to match requests, and if they do match, then capture them using Loop and save them to be able to replay them later.
And kind of the tap configuration. Solo actually contributed upstream to Envoy with the tap filter, which has been merged
so if we come over here 13, to I think Envoy,
that's wonderful.
Look at the docs. So we built Loop on top of the tap functionality that we get out of Envoy. And if we search for the tap config, we should find the tap filter. The internet here's quite slow. Maybe with all of the streaming and stuff that we're doing here.
Oh, for sure.
Well, trust me,
we can see it there. That's really cool.
Right. So then we've created that. Now let's see if we hit tap config and everything. Oh, it's not found. So it must have been around from a previous version. But let's go ahead and create the tap config. That would be in Gloo Loop tap. So let's actually create it.
Nice.
And now if we go ahead and get them, we should see that we've now been correctly configuring Loop here. And now if we come back here and, I want to get rid of, let's just go ahead and clean up those old, the leftover ones from the demo before, which I didn't clean up. So now that should come back.
But I really like this. So the loop loop is very lightweight. The loop controller, loop back is sitting in the cluster. It's a very lightweight component, but I can use the CRDs here that you have the tap configuration, configure my own predicates. So we're just using response headers, but I'm guessing I can literally use any predicate I want to just kind of differentiate and very sort of fine tune which traffic I want to select.
And let me just reset this here, because when I did the bounce of this pod, the 56.
Yeah, kube control doesn't automatically reattach to the new pod when it comes up.
All right. So let's go ahead and try that again. There we go. And now let's try our list. We don't have any, so we're starting from scratch. But if we do tap config, we see we have our tap config there. Now, if we curl into the gateway again, and we see things hang, which we see here, which still determine whether that's internet. Okay, no, that's a real failure there. Let's now take a look at our list. We should see, crossing fingers,
there it is,
a new entry, because we caught that 500.
Yeah.
And so now we've saved off this request because it failed, matched our predicate. And from here, now what we can do is replay that request.
Yeah.
So let's come back over here and let's set up our debugger again. Default payments.
I love
green.
this UX.
Payment, and we'll use Delve. We'll set up the debugger again. Now, instead of calling through the API gateway, what we're going to do is replay that request using loop.
Okay.
And we'll give that a chance to come up. And let's replay our request into loop.
Wow.
And here we go. We see now we have full debug control over our application, as well as the ability to replay those requests. And I can do step over. And this could be in a lower environment, right? So this could be in a totally different environment than production.
I'm speechless. I genuinely think that's incredible. And I hope folks who are watching think that's pretty good. And we'll put all of the links below to a little environment that we've created where you can kind of try this out without even having to install anything, and also the links to Loop and Squash so that you can have a play around. But I really recommend everybody does. So this would make my life 1 million times easier.
Yeah, and I mean this is something that I use quite a bit, even to debug, any services running in Kubernetes.
Yeah.
To debug Gloo itself sometimes, Istio sometimes. So yeah, it's
the thing I love the most about this though, consistency. Like if you go through the whole process, you debug. The purpose of debugging is to find a problem. You fix the problem, or you think you may have fixed the problem. With Loop, I can actually replay exactly the same condition that I was testing previously. There's no ambiguity that I've actually put different inputs in, which has led to the bug magically disappearing. I can 100% be assured of that.
So you can go through and recreate the issue, solve it, and then go through and test that it solved it, right? So then you would get different behaviors if you've solved it correctly.
Very, very cool.
Cool. Yeah. So that's the last part of this section here. So I'm a little sad that we're at the end.
Well, maybe we have to do something else.
I think we need to.
One of the things that I'd love to kind of see, and a lot of work that you've been putting into around the sort of the WebAssembly capabilities. If anybody's not 100% familiar of Envoy, a lot of traditionally, a lot of the plugins for Envoy have been written in C++. And I'll be honest with you, like you don't want me to be coding your C++. It's not something that I've done in a long, long time. And
say.
It's not a language that I'm comfortable with anymore, but now I can use WebAssembly, which means I could write my plugins in anything, compile them down to Go, and they can be hot reloaded, right?
That's correct. Dynamically reloaded. So that adds another layer of opportunity and extensibility to the data plane that we see here. So whether that's at the edge with something like Gloo, or whether that's in the service mesh with something like Consul Service Mesh, right? So WebAssembly allows us to customize the data plane and build very powerful tooling on top of the mesh, like we were just talking, right? So Loop, for example, is built. We built the tap filter into Envoy and some accompanying control plane components. But using WebAssembly, you could do stuff very similar or even more fine-grained than what the tap filter can do today, using your own custom code.
I think that's going to be
so.
amazing.
Yeah, WebAssembly opens up the door for really exciting customizations of what happens to the request on the data plane in a very secure and controlled way. Okay, so that's I would love to maybe spin up a series on that.
I think we'll be back in a couple of weeks, and why don't we come back and show you all how to build custom filters with WebAssembly, because I think that's really, really interesting. I'm dying to learn that.
All right, now I'm less sad. We don't have to come to an end here.
And well, we should do a shameless plug. If anybody is in London next week and is coming to QCon, then please come along, because
the following week, right? The week of March 2nd.
That's right. I think our workshops are going to be on the 5th and the 4th and the 5th, or the 5th and 6th, something like that. It's Thursday and Friday.
Like that, yeah.
Calendars, I ain't good at that. But
yeah, so if you're in the London area, interested in going to QCon, the letter QCon, we'll be there. Come stop by, say hi, join our workshop. We'll deliver this hands-on. You can ask in person, in real life questions. So yeah, that would be great.
And as always, it's been a pleasure, Christian. Thank you so much. Thanks everybody for watching. Don't forget to like and subscribe and smash the bell button for all of those updates. I'm getting good at this. But until next time, farewell.
Yeah, take care, man. Thank you.